Good evening and welcome to the Johns Hopkins University Writing Webinar, Writing That Makes Your Case, Persuasive Language for Engineering Professionals, led by Charlotte O'Donnell. JHU offers free writing webinars to engineering for professional students once a semester. Tonight, we also welcome participants from the force projection sector at APL. Now I'd like to go ahead and introduce our presenter, Charlotte O'Donnell. Charlotte teaches technical and professional writing at Johns Hopkins University. She has worked as a journalist and as a technical writer and editor, publishing across a wide range of topics and disciplines, from medical journal articles to education policy handbooks.
All right, guys. So thank you all for having me here tonight. My name is Charlotte O'Donnell, and I'm going to talk to you guys about persuasive writing at work. So I wanted to start by asking, how many of you have had a communication mishap at work? And what I need to do now is launch this poll. So you've got a yes or no possibility here. Looks like I've got a lot of people that are admitting to communication mishaps at work. About 70% of you guys have voted. Looks like 93% of you guys have had a communication mishap at work. If I can get the last few of you. And then here, I'll end poll, so a couple of you guys might be doing other things, and I'll share these results. So these are the results. And I'll stop sharing. And I'll ask you guys if I can get my chat screen to come up. If I can get a couple of you guys to type a few words for me. Who was involved in your communication mishap? Was it a colleague, a boss, or a whole group of people? How much time and money did the mishap cost you? And in a word, did anyone experience a cost that was worse than just time or money? Can I get a couple people to type in the chat window for me? No, no one? I see a couple. Rocco here tells me that he had a communication issue between himself and some engineers, management, and a customer. Arjit, it looks like, says that he experienced a communication mishap in which trust was spoiled, and it took a while, I assume, to rebuild the relationship. And I'll say right here that, oh yes, past boss, some support, I guess, from that past boss cost someone else some sleep. So that's great. I mean, I think we're all here probably because we've had some miscommunications at work, and I myself have had miscommunications at work. I think so often I work a lot with engineers on communication skills, and what I find is that these kinds of communication mishaps, poorly written emails, poorly communicated things in person, they're really, really common in the workplace. But what is not as common, believe it or not, is that people are actually motivated to make change after these communication mishaps. So what I'm going to do for you guys here tonight is I'm going to tell a story about a time when communication mishaps in an environment basically came to a head. And I'm hoping that you'll see after this story that these communication mishaps can have real serious consequence if you don't already feel that in your life. And I'm hoping that the story basically will motivate you to change. So moving to the next slide. The story starts at NASA in 2003, and the story features the Space Shuttle Columbia. This story revolves around Space Shuttle Columbia's 28th mission. They were going to launch into space to do research on microgravity. And during the launch, I don't know if any of you guys remember this, a piece of insulating foam broke off from, I believe, the left bipod ramp that attaches the Space Shuttle Columbia to the main fuel tank. And this piece of foam broke off of the fuel tank, and it basically ended up hitting the leading edge of the left wing. And this error was a little bit misleading here because when the foam breaks off the fuel tank, what is actually happening is the space shuttle is traveling up into the foam at about 600 miles an hour. So anyway, so this happens, and NASA engineers, they see it happen, and obviously the thing that they want to know is does this foam strike pose a serious threat to the Space Shuttle Columbia's mission? And so what they do is they assemble a team. And they assemble a team to figure out, like, well, what exactly is the risk here? And so this team really, if you're to sort of break it down into very simple terms, they're looking at a pretty simple problem. They're looking at basically the kinetic energy of the debris stripe. So they have to figure out like the mass of the foam, the velocity, both of the foam and of the space shuttle, and the angle of incidence. And they also need to look at the location of the impact. So there's some question when they start looking at the data as to where exactly the foam hit. They know it's vaguely in the area of the wing, but they're not totally sure. And when they combine these two factors, they're able to figure out what the level of threat is to the space shuttle mission. A critical thing to know here is that this had actually happened before. This had happened before, I think on Space Shuttle Columbia's second mission. Another piece of foam had broken off. At the time, they'd actually been really worried about it. And they'd created a model to help them figure out while the space shuttle was orbiting the Earth, whether or not the space shuttle was in any risk. But it turned out that the foam strike during that incident, nothing really came of it. It wasn't really a big deal. So they just sort of, they let it slide. So this new space shuttle mission, we're now on mission 28, and this had happened again. And so the engineering team, that's sort of a mid-level engineering team, they get to work and they start putting their heads together. They go back to that model that's called Crater, and they try and plug in any data that they have about the most recent launch to see what the model's going to tell them about whether or not there's a threat to the space shuttle. And the main thing they're concerned about is, was the space shuttle damaged by the piece of foam? The exterior of the space shuttle is actually much more vulnerable than a lot of people realize at first. It has a number of sort of thermal protective skins on it, but in different parts of the space shuttle, those skins are of varying thickness. There is, in the area of the wing that they knew that it struck, there are two particular kinds of protecting coating. One is a thermal tile, which is pretty thick. It's not invincible, but it's much less vulnerable to damage. And the other kind of skin that's there is something called a reinforced carbon panel. And this stuff is actually quite vulnerable. It's sort of surprising, or it surprised me when I learned about it. You can actually, if you walk up to the space shuttle and press your thumb into this reinforced carbon panel, you can make an impression with your own thumb on it. So anyway, they're trying to figure this out. But another problem that they're running into when they're trying to plug the data that they have into this model is that the camera footage they have of the foam breaking off the space shuttle is actually kind of poor. One of the cameras wasn't working. And so they're really guessing really, really hard about what the size of the foam was. They have a range of sizes of the foam, but they're not totally sure that it's this big or this small. They understand velocity pretty seriously, but another thing that they have a really hard time determining is where the foam hit, because they just don't get good footage. They got some footage of what amounts to kind of like a backsplash from like the foam kind of bouncing off of a piece of the shuttle, but it's really just not clear. So they sort of go around in circles for a bit. They send a lot of emails back and forth amongst team members and to other administrators within NASA that are a few levels higher than them. And they're trying to figure out what to do. And I think what it comes down to amongst the team members at that point is that what they need is better footage or better images of the damage. And so what they try asking for is they want the Department of Defense to help them out. The Department of Defense has a couple of nearby satellites with really high-tech cameras, and the Department of Defense has the capability to actually take a photograph of the wing while it's in orbit around space, or in space around the planet Earth. They really feel that this is probably their best bet to ensure that the space shuttle is either safe or that it's not safe. This is, in their mind, the only way to know. But, you know, in the end, they seem to send a number of emails, and for whatever reason, after a couple of meetings, in addition to those emails, no one seems to be able to hear this request. And what we get sort of in the final meeting that happens in front of decision makers, when the decision makers are set to make that ultimate decision about whether the Space Shuttle Columbia is under threat by this foam, whether they should let it stay up in orbit or whether they should let it come down to Earth, they get this kind of crazy slide, in my opinion. And I want to ask you guys, how many of us understand, maybe by typing in the chat field, let me know, exactly what this slide is trying to say? And just like a resounding yes, if you feel like it's a yes. Yes, someone says, not me. Too wordy, someone says no, another person says good. I'm really glad that you can't make sense of this, because at first, like when I looked at this, I'm like, well, I'm not a NASA scientist, so like maybe I just don't know better. Someone says, I'm sure it says something. I'm just looking for a one-liner on the decision. Good, okay. Here's another question then, and I'd love a word or two response in the chat field. In a word, what to you makes the slide so confusing? I see some people saying wordy. I see another person saying they're looking for a one-liner on the decision to make. Anyone have like another, so there's like a lack of like a concise one-line message. Anyone have any other observations? Someone's making a note like the audience, somehow there's like, the audience is off, or like the author of the slide isn't considering the audience. I'm glad you're saying that. We'll get to that. Yeah, acronyms. Someone is mentioning SOFI. SOFI is confusing. Too much information, complex. Really, really challenging trying to figure out what the message is here. If the audience is technical, I like this person. RG, he notes it might make sense, but probably not for a general high-level crowd. All of these things that you're noticing are right. The audience for this slide, William Perkins is asking, it is the high-level decision makers at NASA. They have some technical knowledge, but you know, their technical knowledge isn't infinite, and I have a lot of things to say. I have a lot of things to say about how we could work a little bit more clearly with the particular audience that is supposed to be receiving the slide. Here are a few things that I like to note about this slide. Okay, one, and you guys have all noted this, so many bullet points. Two, really wordy, and yet so fascinatingly to me, not a single complete sentence on this slide. There are these kind of fragmented sentences that are out of context, really critical context. I think if some of you guys look at the slide in a little more detail, you'll note that there is an attempt to relay a message at the top. Review of test data indicates conservatism for tile penetration. The title of the slide is trying to say, if I untangle this a little bit for you guys with the knowledge of what people in NASA were actually saying to one another at the time, they were trying to say, we kind of think that it's okay, that the shuttle might be safe to come back down to Earth. But if you start to sort of go through the lower bullet points in the slide, what you'll notice is the lower bullet points get sort of increasingly, they sort of increasingly sort of let out warnings, like point to problems with the recommendation that's made in the title line of the slide. So they contradict the title line of the slide in a way that I think would make me worry if I had the technical knowledge needed to make this decision. Another thing that some of you guys have noted is there is a lot of jargon on here. You note the acronym SOFI. What SOFI stands for is spray on foam insulation. So that has to do with the foam that hit the wing. We've got this other acronym at the top, STS-87 Southwest Research Data. This is actually the second mission of the Space Shuttle Columbia, the data that was gathered from the first foam strike. If you go down to the bottom, there are others that I haven't highlighted. There's a place where they mention the volume of the ramp. That's actually just another way of saying the foam debris that hit the wing. We have cubic inches sort of written in a bunch of different ways across this whole PowerPoint presentation that they gave. So the whole thing is sort of littered with jargon that's pretty challenging. And then an additional thing that I'd like to point out to you is sort of this troubling use of the word significant. And the slide seems to overuse significant to the point where like every single line almost uses the word significant. But if everything is significant, then to a lay reader, and certainly to a high-level decision maker, nothing is significant, right? Because if everything is very important, then like it's hard for us to tell the difference. And each of these uses of the word significant, they have very different meanings. Like some of them mean like kind of mildly significant, and others mean like super, super, super important. And also, strangely, none of these uses of the word significant refer to statistically significant, which I find kind of strange and troubling in a presentation that's really meant for NASA engineers. So the slide is confusing, and NASA administrators, they take a look at it and they're like, well, I guess it looks okay. I mean, we don't really see the problem here, so I guess we can let the space shuttle come back down to Earth, right? But then what we had is this incident, which you all probably read about in the news when they let the space shuttle come back down to Earth. Turns out there was a hole in the wing that the foam had caused when it hit the wing of the space shuttle at 600 miles an hour. And the hole in the wing let heat penetrate through that thermal layer that protected the space shuttle, and it basically disintegrated upon orbit, or upon re-entry into the Earth's atmosphere coming out of orbit. So here, I mean, and this is sort of like a kind of a joke question, but just to see if you're paying attention, I'll launch this next poll. So can we guess what were the consequences of this communication mishap? We've got the loss of 7 highly trained astronauts that are estimated at about $50 million apiece just in terms of training. We've got the loss of the Space Shuttle Columbia itself, which is estimated at $2 billion in 1978. And we've got the cost of the cleanup and the investigation of the accident, which was $400 million, or we've got all of the above. And it seems like most of us are choosing all of the above, which is actually, unfortunately, the answer. It really cost NASA an outrageous amount of money. And all of this over a communication problem. So I will, and thank you all for participating. I will end that poll and I'll share the results. And I'll move on to the next slide. So, I mean, the point of my presentation here, or what I'm trying to argue with you guys today, is that, well, one, I should step back and I should say there was a huge investigation into this accident and what caused the accident. And the investigating committee, they definitely found that there were huge problems with communication, which I think were kind of like the final straw that led to the explosion of the Space Shuttle Columbia. Underlying that communication problem at NASA, though, and tangled up with those communication problems, were definitely big, systemic, sort of institutional culture problems. They had a kind of institutional culture at the time that prevented clear communication, or certainly didn't encourage it. But I'd like to think that there's a world in which if we were able to solve those big institutional problems that sort of caused the communication culture to be as it was, and institutions do solve those problems all the time. If we're able to do that, there would have been a way to avoid this giant disaster that happened to the Space Shuttle Columbia. And the way we could have avoided this disaster is if the authors of that slide and the members of that team that were investigating the accident, if they'd thought about communicating sort of in 3 ways. There's sort of 3 principles I'm going to talk about today. And the first way that I'm going to talk about is if they thought more specifically about their audience's need. The second thing that I'm going to talk about is that what they really needed to do was put their point or their recommendation up front. And the third thing that they needed to do was communicate with clear and easy to read sentences. A lot of times you guys might hear clear and concise sentences. I have a slightly different way of thinking about it. Concision, I think, is embedded in everything I have to say. But I will explain more of that as we get further on into the presentation. So, to principle number 1, audience needs. What I have to say here is that a lot of people think that the key to convincing someone of their point is actually to show that person how great their content, their ideas, or their research is. But what we know from social science is, unfortunately, that is absolutely not true. In fact, in many ways, the opposite is true. It doesn't matter how great your ideas are. What matters is how people hear it. And what I mean by that is that the way human beings process information of any kind, no matter how technical the information is, the first line of defense or the first way we take in information is through our emotional or intuitive centers in our brain. And it's only after the information comes through our emotional or intuitive centers does our rational brain get to it. A sort of terrifying study done with a group, I think at NYU, a social science group at NYU, they basically found that almost all rational thinking is used to justify emotional responses, which I think as a STEM professional can be really terrifying. But it doesn't mean that there is no hope for you. It just means that you have to take a person's emotional response really seriously before you begin to craft a message to a person. I think, especially when we're working in more technical fields, our first intuition when we're writing a message to a boss, because maybe they don't have the same technical training as you, but they have some technical training, our first response is, well, you know, these are scientists, right? These are rational beings. So because they're rational beings, I need to put all of my factiness, all of the greatness of my ideas, all of my evidence up front. But more important than putting your evidence and your important ideas up front is actually considering the particular needs of these human beings. And these are two really critical people at the top of the NASA organization at the time. We have Linda Ham, who ended up losing her position, sort of getting moved down the ranks after the Space Shuttle Columbia disaster happened. And Linda Ham was sort of not quite second in command, but she was the person right underneath Ron Dittemore. And Ron Dittemore was the manager of the Space Shuttle program from 1999 to 2003, at which point he left. And in any case, what these people needed, even if they'd sort of told you the opposite, was not so much data as it was for them to sort of be considered as people that are human, that are flawed, that were under a lot of pressure at the time, and whose situations were much more complicated than just being like simple STEM professionals. I think a crucial thing to know about the miscommunication at NASA that happened during this incident was that Linda Ham was the person who was receiving most of the information from the lower level or mid-level teams that were investigating the foam strike. And she then in turn would communicate that information to Ron Dittemore, who was ultimately the person who was in charge of making like the high-level decision about what to do with the space shuttle. But they had a very close relationship, and she guarded it very, very cautiously. So, you know, if we were to put ourselves in the shoes of the team that is investigating the accident or that investigated the accident at that time, I think a better thing to do would have been to look more closely at the specifics of who Linda Ham was as a human being. And, you know, in communication, we really talk about this as knowing your audience. And the first thing that you need to consider when you're working with any particular audience is you need to to ask yourself, what do they expect of you, or what have they asked of you? And in the case of this research team, what Linda had asked of the research team that was looking into the disaster was a brief communication about safety and its implications for the mission. Critical. Seems simple, but very, very important if you miss it. The next thing that you have to think about when you're considering audience, and this is also really easily overlooked all the time by people that are trying to communicate. How much time does the person you're trying to communicate with have to give you? And in the case of Linda Ham, she had a lot of things on her plate. She had a lot of teams trying to communicate tons of data to her every single day. She was very, very, very busy decision maker. And she really didn't appreciate it when someone went on at length trying to describe their project, what they wanted, what they needed, etc. The next thing you should always consider, and this is an interesting principle, or it's an interesting model for understanding communication in the workplace. There's a thing called communication style. And when we talk about communication style, there are 4 types of communication style according to a pretty common model. The first is kind of an analytical communication style. This kind of person wants the facts, wants to get it right more than anything else. That's their #1 priority. A driver communication style wants it done now. They want it done in a timely manner. That's the more important thing. There's an expressive communication style that's more interested in like novel ideas and creative vision, not loosey-goosey creative. I mean, there are plenty of expressive people that work in technical fields, but they're the kind of people that are really interested in innovation. And there's a 4th communication style whose main priority is actually to involve every member of the team to move the group together. But if we looked back at Linda, and if we sort of, I've concluded this by looking at her testimony and also just looking at general communication types that end up in higher management. So I don't know her personally, but this is what I've deduced. She's probably a driver. She really, really, really wants to get things done right now. And part of that had to do with the rest of the context around her at NASA at the time. You also obviously need to consider every audience member's biases. Linda had some negative experiences with data collection projects. She also tended to prefer flight planning over like data collection. Data collection was slow. I think she'd had some bad experiences in the past. And so she doesn't hear things as well when they have to do with getting more data. And then the last thing that you need to think about is any other priorities. So Linda was really interested in prioritizing working relationships within NASA. When you start involving people from outside of her organization, things get touchy, things slow down. She didn't always have good relationships outside of NASA. And she was also particularly sensitive to maintaining a good relationship with her boss. So if something was going to upset Ron Dittemore, she was going to be pretty skeptical about it. So sort of knowing these preferences, knowing Linda really well, we can look at these 2 emails. I'll read them aloud for you guys, but you can guess in a second which email will resonate better with Linda. We've got email A, and email A is like, hey Linda, how are you? Okay, I hope. Have you looked at that spreadsheet I sent you last night? Lots of numbers, I know. I wanted you to be able to see yourself. Some things about them trouble me. We aren't modeling the conditions during liftoff accurately. I mean, 19 cubic inches versus 3 cubic inches. I'd like more data. Your boss, Ron, won't like it, and there's a chance it won't tell us anything, but we should really ask the DoD to photograph the wing to see if there's damage. Or there's email B, Linda, comma, I believe the incident poses a serious threat to Columbia's mission, period. The model we've been using to assess the damage is highly inaccurate. We shouldn't trust it. On top of this, analysts on my team think that the debris hit a more vulnerable part of the wing, which it did. It hit the reinforced carbon panel. We need to ask the Department of Defense to photograph the wing. I understand that Ron won't like this slowdown, but I believe it's the only way to ensure the safety of the shuttle and its crew. Now it's your turn to tell me, I think this is, yep, I'm going to launch this poll. Which email will resonate more with Linda, A or B? See a lot of B's. Yep. Especially for a driver type. And I should also say, some other students that I've had in the past when I've showed this example email have pointed out to me like, well, actually, is there any kind of boss person that would like email A at all? And I think my answer to that is, I mean, I wanted to make this answer obvious to you guys right now. I would say there are very few boss people that would find email A to be effective, but depending on their communication style, there might be a boss person that is more tolerant of introductory lines that sort of show connection, try to establish a rapport before you get into the data. So that's just to answer your question, if that has come up in your mind right now. I'd love it if a couple of you guys could type into the chat window, what do you notice in a word or two that makes the second email more effective, given what I just said about the components of how you have to think about an audience? Yeah, it's decisive, straight to the point, to the point. Good. Anyone else? It sounded more direct. Yeah, it does absolutely sound more direct. There's a big reason why. States reason why they should take action, acknowledges repercussions. I like that right there. Bottom line up front. Oh, there's a comment that's straight to my heart. Good. Yeah, structure is clear, answers the question first, explained uncertainty, directed an action. All of these things are true. You know, it doesn't dally, it gets to the point. It doesn't linger on data. You'll notice email A is like, it seems to suggest that this person sent her a spreadsheet of numbers the night before. There is no way that would fly with Linda. She does not have time to go through your spreadsheet and run a bunch of formulas herself. You'll also notice that email B, what it does is it sort of acknowledges that Linda might be in kind of a bind with Ron by receiving this information and having to relay this information. And that small act of sort of sympathy, of acknowledging that this situation might actually cause her difficulty. I know that seems like a small thing, and a lot of us absolutely see the decisiveness of the email as being like really, really important, but just as important are some of the things in the lower paragraphs where it's clear that the person who's writing the email to Linda is trying to make Linda an ally. It's trying to sort of be on her team and support her. I think you might be surprised at how often people just discount your message without recognizing that they've discounted your message just because they have a gut feeling that like you are a person that's trying to be difficult, or you don't know what you're talking about, or et cetera, et cetera. So a lot of you guys, I think, absolutely, and I'll end poll, and I'll share your results, and you'll see that 100% of you got this question right. So a lot of you guys have pointed out this particular principle, which is, I think, like the baseline standard for how you communicate more effectively, in particular in the engineering profession. A lot of you guys work with a lot of technical people all the time, and I probably get a sense that you've all had some team members that at one point or another, because of the nature of complicated projects, maybe they got a little down in the weeds, or perhaps a lot down in the weeds. And it's all too easy for that to happen. But the critical thing, after you sort of assess specifically your audience's needs and think of them as a more whole and complex human being, the next thing you need to do is you need to put your point up front. And in the way I teach points, I like students to consider two things. What do you want to say? And also, why should the person that you're speaking to care about it? What really matters? There's another way of thinking about this if you're sort of especially hung up on this second part of why a person should care about it. You can think about making a point with two components. The first component is always like a serious problem. A serious problem, what's implied in a serious problem, is a reason to care about the topic that you're presenting. And then the next thing that you need to think about is how that problem connects to the audience's interests and needs. Beyond that, what I want to say, especially to you guys in the engineering fields, is that bottom lines aren't neutral or objective. I know that there's a certain kind of work in your profession that really encourages you guys to stay neutral, to use the scientific method as much as possible. You're taught like crazy to avoid bias, but you're taught like crazy to avoid bias when you're making your devices, when you're testing things in the lab, so that ultimately you can make a case more strongly and present an opinion, an interpretation. And your communication is going to be much more effective if your opinion that you express is strong. I would encourage you to move away from wishy-washy opinions, because wishy-washy opinions, sometimes they confuse people. It's not that there's no place for them at work, especially when we have to soften our message, but more often than not in the engineering professions, I see people having their message get lost because they're not being direct enough. And so here, and the last thing I have to say about putting your point up front is that the shorter the communication is, especially like in email, the quicker you need to make your point, which is I think one of the reasons why email B absolutely resonates more. So emails, your point probably needs to be the first line of the email. A longer report, I would say your point probably needs to be at minimum at the end of the first page. It varies by document, but consider the length as a factor of where you put your point. And if you notice that you're putting your opinion, your interpretation, your recommendation midway through or even at the end, that's not going to help an audience stay on track and understand where you're going. I see. Yeah, I see that. When we ask what time it is, don't tell us to build a watch. I've never seen anyone convinced with someone's opinion. In fact, I see it often go south. Definitely resonate with that. Yeah, no, I mean, I think this is true. You know, another thing to think about, like sometimes when I bring up that people process things through emotion first, today's political climate is absolutely an example of people being really, really difficult to convince. And so, you know, it might be the case that you're communicating with a person who you're not going to be able to convince, but you have to do your best to express your opinion directly in a short amount of time. Usually what they find, what it takes to convince someone and change their mind over time is it basically just takes time. It takes time and it takes sympathy. And so you're never going to get anywhere if you're wasting anyone's time, which is a reason to put your point up front. So here's some things that are examples of like not really making a point. And so what we have here, this would be an example of not a point. We have one model uses 3 cubic inches, but the real world situation involves 1920 cubic inches. This refers to the size of the foam. The first foam strike, actually, the measurement on the foam in the model was really small. It was just 3 cubic inches, but the foam for the Spatial Columbia was much, much, much larger. In any case, this isn't interpreting this fact in any way. This isn't an opinion. So this wouldn't be something that would be useful to put at the top of any kind of communication. Another example of something that's not quite a strong opinion is to put something like, I'd like more data up front, you know, especially for decision makers that might not be on your side. I'd like more data seems like, well, maybe you'd like more data, or maybe I'll ignore this request, as was the case of a lot of people that they asked for permission to use cameras on the spy satellites. They were sort of like, it seemed like soft, kind of wishy-washy requests. They sent this request to a couple different people to photograph the wing, and they were basically ignored for various reasons, and no one meant to ignore them, but no one could really hear them. So when in doubt, make it more than a personal request. Make it something closer to this. Here, we've got a statement that is arguable, at least. We don't have enough data to make the right decision. And it's arguable. The one problem that I would say about it is that there isn't really a compelling problem that's attached to it. So a better version of a point to put up front is a sentence like this. If we don't collect more data, we're risking the success of the mission and endangering the lives of our colleagues. This has a compelling problem and a shared context. You'll note what Linda cares about is the success of the mission. She cares about how the space shuttle moves around the Earth, that it comes up and down on time, and that everybody is okay. And so this is the kind of point or interpretation of data or the situation that is at least going to be something that she can hear. It might not be something she'll agree with, but she would hear it, which is half the battle. And so what you'll notice here, I'm just bringing up these same emails again. The bottom line in email B is really right at the top versus email A, the bottom line is like way at the bottom. And I think you guys all intuited this immediately. So when in doubt, put your point right at the top, cut to the chase. Okay, beyond that, what I have to say is that it is important to write in a way that is easy to read. I talk about this maybe a little bit differently than some other writing instructors might. I teach principles in my technical writing class out of a text called Williams. And he talks a lot about how the reader's attention and their focus is really, really precious. You have to consider every time you walk into a room, the audience that you're delivering your message to, whether it's in person or on paper, they already, before they've even heard you speak, they have a couple of things on their mind. And it might be that email that they know they need to send to their boss that has nothing to do with you. And also probably worries that they have in the back of their brain about the budget. Linda had a lot of worries about the budget. She was distracted from the message that the other team was trying to communicate to her. Maybe they're worried about a confusing thing that another colleague said to them earlier in the day. Maybe they're distracted by that buzzing light overhead in the meeting room. But anyway, by the time they get down to you, they've only got a little bit of attention left. And if you start to worry them or distract them with that typo in the first line of your email or your report, that jargon that they remember, but like it takes them a second to remember it, or like that sentence that's a little bit too hard to parse, boom, they're out of attention. They're no longer focusing on the message you're trying to deliver them, the opinion that you have. What they're focusing on are all of your typos and other things. So don't waste that attention. You have so little of it, and it takes so little to turn the reader off. I'm gonna basically show you these two passages, and I'm hoping that they will illustrate these principles in action. I'm gonna ask you guys after I read them, which one is clearer. I will read them out loud right now. The TPS breach in the leading edge of the left wing, which happened because of a piece of insulating foam which separated from the external tank at 81.7 seconds after launch and struck the wing in the vicinity of the lower half of RCC panel number 8, caused the accident. Superheating of material on re-entry amounted to penetration and melting of the edge insulation, which subsequently led to disintegration of its structure. This resulted in a weakening of the structure until increasing aerodynamic forces caused loss of control, failure of the wing, and breakup of the orbiter. Communication was lost by mission control at the point when the wing began to fail. That's passage 1. We might imagine that that is from a report that describes the accident. Passage 2, or B, is this. The physical cause of the accident was a breach in the thermal protection system. This breach occurred 81.7 seconds after launch when a piece of insulating foam separated from the external tank and struck a vulnerable part of the lower wing, reinforced carbon panel number 8. During re-entry, a crack or hole in this panel allowed superheated air to penetrate through the leading edge insulation and progressively melt the aluminum structure of the left wing. In time, aerodynamic forces caused the wing to fail, which caused the shuttle to lose control and break up as it entered the atmosphere. Though early stages of the damage went undetected, mission control lost contact with the shuttle shortly after the wing began to fail. I am going to go back to my polling feature, and I am going to pull up poll question number 4, and I'm going to launch it. You guys tell me, in particular, think about that lay audience or the busy decision maker. What would they find clearer? And I see again, we have B. B is clearly winning. Good, good, good. And I mean, just for the sake of this, I'll just end the poll right now and I'll share the results. And I'm going to walk you through why. There's some very particular things about the difference between passage A and passage B. But actually, before I walk you through, how about you tell me in like a word or two in the chat window, what makes B clearer? Do you got a sense? Or what makes A unclear? Short sentences in B, less unimportant details in B. Okay. Other things? One of the interesting things to note, remarkably, is that A and B are nearly the same length, but actually B, which is clearer, is a little longer. It does seem like B is less technical than A, although I have some other things to say about that. There's a kind of cult of like serious science writing that exists out there. I would say that a lot of that serious science writing that we read in some places, it's not actually the kind of writing that most of the best STEM communicators out there encourage people to sort of partake in. There's a kind of way that A sounds that does sound more technical, and it has to do with the subjects of the sentence. That is my hint to you. I'm going to sort of walk you through a couple of principles. The first thing that B is doing a lot better than A is that A is using a remarkable amount of jargon and acronyms. And as I said, you know, there's definitely, I would say that the top level decision makers at NASA, they probably understood these acronyms because this was part of their daily job. These were super highly educated people, but they don't have like tons and tons and tons of attention to give to you. So the more that they're made to work through sort of untangling these acronyms, remembering them, remembering how these principles work in practice, the less attention they have to give to the rest of the passage. And there are plenty of other hurdles that the author of passage A is asking an audience to sort of jump through in order to get to the message. So avoid jargon at all costs. When in doubt, what you really want to do is you want to spell out all acronyms. Even if you suspect that your audience knows the acronyms, you want to use plain language just to ensure that your audience member absolutely follows you to the letter. The second principle, some people have noticed, sentences definitely need to be shorter. Shorter sentences are typically easier to follow. I will say I am pro long sentences as long as you do long sentences well. A reason to keep to shorter sentences in technical documents is because you are always juggling a lot of different concepts and ideas in technical documents. It is hard for the human brain to parse lots of different technical information in a sentence. So it's better to have shorter sentences where each sentence introduces one new technical term than to have one long sentence which introduces 3 new technical terms. It's basically just how memory in the brain works. So when in doubt, keep sentences short. And the second principle, I don't know if it will surprise you, but what you might notice is in the unrevised, in passage A, we have the subject, which is word 2 and 3, or the acronym that is the second word, and the word breach. That is word 2 and 3 in the sentence, and the verb is way the heck at the end of the sentence. And that is something that linguists have studied. And in English, it's actually very challenging for readers to understand a sentence if you split the subject and the verb really, really far apart. And so that's one of the reasons why not only is this sentence long, but it's long and super hard to understand because the subject is way at the front, and then we have all this other weird information in between, and then only at the very end do we get the verb. And it's also one of the reasons why I suspect, a number of you guys were interpreting the first passage as containing sort of irrelevant information. It seems irrelevant when it's junking up the connection between the subject and the verb. When in doubt, you want subject, verb, object right away. Try to put the subject and the verb really close together. So we have here, physical cause of the accident was a breach. The breach occurred. And then, yeah, and the sentence goes on from there. So clear, direct sentences have subjects and verbs that are really close together. The next principle that a lot of people don't know about or don't talk about that much is this principle of the kinds of subjects and the kinds of verbs that actually make sentences easiest to understand in the English language. And the kinds of sentences that are easiest to understand in English are ones that focus on concrete objects. In particular, we say people and objects make for the clearest sentences in the English language, something that we can actually visualize in our brain as we read the sentence. So concrete objects followed by really strong sort of dramatic verbs rather than versions of to be. Or to seem, or other verbs that are more like linking verbs rather than action verbs. A thing that sometimes happens when we're dealing with technical concepts or technical documents is one way that authors that maybe don't know any better try to make themselves sound more important is they make the subjects of their sentences something that in the writing world we call a nominalization. But basically we'll stick to nominalization. And this is the idea of there's a verb in the sentence that's been turned into a noun. And so here what we have is this verb that's penetration, so penetrate. It's been turned into a noun and it's been weakened by being turned into a noun. And also at the beginning of the sentence, you could think of heat as a verb, like to heat something. But when we put superheating as the subject of a sentence, it's a little harder for us to visualize. A sentence that will be easier for us to follow and visualize will feature a subject that is easier to see. When in doubt, if it's possible, I strongly recommend that you use the we followed by a verb. Here in the case of this sentence, what we've got, I have a little introductory clause during reentry, and then we have a crack or hole in this panel. And so a crack or a hole is something that we can touch in the real world, and it's going to be easier to follow. And the crack or hole allows air to penetrate. So when I've turned this nominalization back into a verb. And the last thing that I have to say that sometimes is a little controversial in different research fields in engineering, but is absolutely supported by top STEM writers in the field, is when in doubt, you should really try to avoid the passive voice. The gist of strong writing are those subject, verb, object sentences. And the reason why subject, verb, object sentences are so effective is because it makes it very clear who does what. And so we have a concrete person or a thing followed by a dramatic action verb, and we understand in English what you mean. Passive voice is not evil. It has a place in the English language. It may even have a place in your technical reports, but from a grammatical perspective, what passive voice is really supposed to be about more than anything is helping you get out of tricky places in a paper where you sort of have to invert old information and new information and do a little bit of language gymnastics, I think, for lack of a better term. It's meant to be connective tissue. It's not meant to be the main structure of the paper. or the email or what have you. So most readers in the English language, if they were given the option of these two sentences, they would choose option 2, that is the revision. Mission control lost contact with the shuttle shortly after the wing began to fail, because it's clear who is doing what. There's a version of the unrevised sentence that would just say something like, communication was lost at the point when the wing began to fail. There's some instances in which maybe you don't want to lay blame on a particular person, and you use the passive voice for that reason. But I'd say that by and large, you should be really, really careful about using the passive voice, because it can very easily deceive. And there's a history of different institutions and governments and what have you using the passive voice to deceive. So I guess I will close with this final poll. How about you try to tell me which of these sentences is clearer? The sentence that starts with review, which is like a little bit harder to maybe visualize, or the sentence that starts with we? Yeah. Here, and I'll end the poll. And we have one person that likes 1, and it's not that 1 is incorrect, or that A is incorrect, but I'll note to you that, like, a review of test data indicates conservatism. What's confusing to most readers about sentence A is that whose conservatism, or what does the conservatism belong? Does it belong to the decision maker? Does it belong to the data? Does it belong to the tile? But B, it's very clear, we believe something, and so the action and what is happening are easier to parse. And then I've just got one more for you, and I'll move on to question 6, and I'll launch poll. And this is, in case you're not clear, one of these is passive voice and one of these is active voice. And like I said, I don't want to beat up on anyone for using passive in every once in a while, but I'm hoping to convince you that most of your paper shouldn't be written in passive. And I am seeing that most of you guys are choosing B because NASA administrators is a clearer subject, and they misunderstood the engineering team's presentation. So good, I'm really glad that you are all with me on that. And yeah, so that's the gist of everything that I have for you guys tonight. I wanted to open it up to questions. I know we're already at the end of time, but I would be happy to answer whatever you have to throw my way. Oh, interested in a good use of passive voice. I have, Jeff, if you send me your email, I can send you some exercises from a book. A lot of good uses of passive voice really rely on context. And I'm completely enamored with a text, or with a book from Williams. It's called Elements of Style. And I will happily send it your way. Anyone else have any other questions? Would I say blunt communication is good? Yeah, it definitely can hurt feelings. Rocco, I think you are absolutely right. You have to be careful. And this is an instance in which considering the person's communication style that you are speaking with is absolutely important. And also you need to consider their other needs. So any biases, you definitely don't want to offend anyone. And are there any good books for engineers as it pertains to technical writing? Yes, I do. I do have one. Give me a second to finish answering Rocco's question. I think a lot of it, you have to know who you're talking to. It's better, especially in situations where there are dire consequences for your message not being received, for you to be direct. But you know, some of interpersonal communication that takes practice, you learn to balance directness with a kind of softening, not of the message, but a kind of like writing in sympathy in different parts of your communication. So this is where that instance of the email to Linda, where it acknowledged that this particular request was going to put her in a bind with Ron. That's the kind of thing you should think about doing. If you are worried that your audience is sensitive, if they seem tired or taxed in any way, I always tell my students it's super wise when in doubt to open with a thank you. Expressions of gratitude can go a long way. To close with a thank you too. I hope that answers your question some. I definitely am going to send Jeff an example of some interesting use of passive voice. In terms of good books for technical writing, what I would recommend, so there's a great book by an environmental scientist, but he has collected a whole bunch of examples from writing across the STEM fields. So it would absolutely apply to engineering. And it's called Writing Science. And if you send me your email, I will happily send you a link to that book. I believe his name is Joshua Schimmel. But I swear by that book. And that book does a great job of sort of explaining all the complications of how to tell a story in technical writing, and not it be like a fanciful story, a direct story that shows a reader why they should care. It also talks a lot about methods to be more direct when handling really technical material in writing. Other questions? Yeah, I will send you the links as well, Rocco. Oh, I wonder if it's on Audible. And Eric also would like some. Okay. I will keep all of you in mind. I think at this point, Heather, should I, oh, one more question? Rocco, I'm happy to answer another question if you want. So if you guys would like, here's what I'll do. I'm going to write my Hopkins email in the chat right now. And how about you guys email me, given there's so many of you, and I'm happy to pass along all of these links to you. Rocco, did you have another question or? Given that we're sort of past time, oh, on reading people. Yeah. I think that this would actually be a really useful, yeah, no, it's okay. This would be really useful. Let me send you a link to the books on communication style, because that I think will be really helpful to you on reading people. Super common problem. Interpersonal communication causes, yeah, it causes mishaps all the time, just as much as poor writing does. And I absolutely feel you. It has been hard for me as well. And I think most people actually find that I'm a pretty sensitive person. So it's challenging, I guess is all I'm trying to say here. Thank you guys for being such a wonderful audience and so participatory. It's been lovely sharing this stuff with you tonight. And I hope you have a good night.